All right, here we go. We're going to talk a little bit about Chapter 8, discounts and interest rates and all those types of interesting, wonderful things that you got to love as a banker anyhow. So let's take a look. I like to look, and you've got them written down, but if you go to page 248, 249, I think all the formulas that we're going to use for the problems today are on those two pages. And I love Excel, and I do a lot, believe me, but it also helps me a lot to have those things written out and in front of me. And I've done that to a certain extent here, and writing them out like this, which would take you guys a decent amount of work. But if you just did it, on a separate sheet of paper while you're working on it, I think it would help quite a bit in figuring these things out. So I think I showed here, I set up this formula. And the reason I did this is because you guys have 1, 2, 3, 4, I think 4, 5, something like that, problems where you're going to use this same formula. And you can just duplicate the setup, I guess, would be a better thing to call it, and then make it pretty easy. So called it calculating the cash discount, and here's just all my inputs, right? What the discount percent is, what the discount periods are, and the final due date, the percent at final due date, which is generally going to be 100%. Days of the year we usually use 360. I think that's what the book asks for. So to be consistent, please do that. And then I just put in the formula here, right? And it's the discount percent divided by 100% minus the discount percent times 360, our days per year, divided by the final due date minus the discount percent. So it's 2% divided by 98%, right, times 360 divided by 50. Okay, but we can put that all in a formula, and we can say it's equal to, we're going to need some parentheses here, but the discount percent divided by the 100% minus the discount percent. So I need another percentage, and I got my 100% here, so I can do that minus my discount percent, and then take all that times, and I'm going to need some parentheses, 360, which I have up here, divided by parentheses the final due date, or 60 minus the 10, and I'll need a couple parentheses. I think I'm missing one parentheses. There I am. Okay, I think I've got everything there. Let's hit enter and see what happens. 14.69, and that's what I had before. And there, it's done. Okay, so now when I go to problem 1, right, I got the same exact thing. So I didn't have to. I hope I didn't do one. No. Okay, so I can just take this, okay, I can copy that, come over here, plug her in here, and there we go. Okay, now that plugged in the numbers, right? But what do I have? I have 210, so my discount percent is 2%, 10. My final due date's 40, so I can make that change. 100%, 360. I think everything else is done. So yeah, once I get it, then it's pretty easy. Okay, this is just breaking down the formula, and you can certainly do it that way too. I broke down the formula each way. I broke down the formula. I did this side, the left side, and then the right side, and then multiplied the two together to come up with the same number. And you can sure do that in Excel. Sometimes that's easier as well. So, I did just the left side of the formula, so discount percent divided by 1 minus the discount percent, or 100% minus the discount percent. Okay. So once you do that, you can copy, copy and paste it into a blank if you want. Oh, I did your guys's up here. Shame on me. It's not what I meant to do. Darn. There, that's what I had, was 310. So don't cheat and use the answer that I just gave you. Okay. Then you can copy and paste it down here, and away you go. Gosh dang it. Okay, and then guess what? You can copy and paste it here. Now I did ask you to, in number 2, explain why, and what it asks is the second part of the question, I think, says, should the firm borrow the funds, and why? Okay, well, if you're, and I think in your guys' case, and I did number 3, and it's the same, and I just copied and pasted, and I came up with the cost of not taking the discount is 15.66%. So should I take, should I pay 17% and borrow money from the bank, okay, in order to take the discount? No, because I only save 15.66%. On the other hand, if my discount percent up here were, say, 2, okay, I would save almost 21%, right? And so it would make sense to borrow money from my bank at 17% to save almost 21%, right, for that 45 days. And then I should pay it off 45 days. So we do that to make that comparison, given our cost of funds. And, if we go back, or I think that's coming up actually when we'll be talking about cost of capital. And that's really what we would use. If our cost of capital is less than, okay, the discount rate, then we should, borrow money in that case, or use our capital, but borrow money in that case in order to go ahead and take advantage of the discount. So there's kind of your answer for that one as well. Okay, we get to question 5, which is just like your question 4. It says a pawn shop. Yeah. By the way, pawn shops make pretty good money. But a pawn shop will lend $2,500 for 45 days at a cost of $35 interest. What is the effective rate of interest? So we need to find the effective rate of interest. And if you go to, again, it's up on page 249, so it's right above us on that same page. Okay, the effective rate of interest is the interest divided by the principal. So the amount of interest, not percentage, but the interest divided by the principal, okay, times the days in the year divided by the days of the loan outstanding. Okay, so it's this divided by this and this divided by this, and multiply the two together. Okay, and so I just did it in 2 phases here. I'll just delete this and show you the 2 phases, but okay. See if I come up with that same 11.2. So I've got the interest divided by the principal, so I can hit simply equals interest divided by principal. And I've got then the second part of it is the days in the year divided by the days of the loan outstanding. So I hit equals the days of the year divided by the days of the loan outstanding. I should have entered that whole thing in there, but I didn't. And those two are multiplied by each other. If you look at the formula, it's the 2 sides multiplied by each other. So I can simply say this is equal to this times this. And lo and behold, I come up with my 11.2%. So that's just to figure out an effective rate, simple interest, we would call that. And away we go. 6, which is much like your 7, I think. I'm sorry, no. Let's see, I did 5, which is like your, the heck, 5 is like your 4. Okay, and then you guys have 7 and 8. And I did 6, which should be similar. Yeah, because we talk about discounted. Okay, so we're going to talk about discounted. And you have one that's discounted, and then you have one that's a little bit more complex. So I've kind of got them combined on here to talk about them. So you have to read it. And then the question says, Saul Pine borrows $5,000 for 1 year at 13% interest. What is the effective rate of interest if the loan is discounted? Well, if you borrowed $5,000 for 1 year at 13%, the amount of interest that you would pay, and then I'll talk about discounted loans, but the amount of interest that you would pay is simply the two things that they've given us. They've given us the amount of the loan and the interest rate. So that's equal to the interest rate times the amount of the loan. Okay, so that's the amount of interest we would calculate. Now, a discounted loan says you pay that interest up front, right? You actually pay it up front. So technically, and this is how we calculate it, technically what you're getting is, instead of $5,000, you're getting, just to give you an idea here, the $5,000 minus the $650, because you're paying the $650 up front, right? So they're going to give you $4,350, and you're going to pay back $5,000, so $650 in interest. Okay. Well, Jesus, isn't that the same? No, it's not. And the reason is because when you calculate that this is what you're getting and this is the interest that you're paying, okay, the rate is going to be higher. Okay. If we look at the effective rate of a discounted loan, it's equal to this. Okay, interest divided by the principal minus the interest times 360 divided by the days of the loan outstanding, or 1 year. And so for this particular equation, they gave us a simple one. They said it's outstanding for 1 full year, and so 360 divided by a year, 360 is 1. So this side of our equation is simply 1, which means times anything times 1 is itself, so we don't really have to do it. And so it's just the interest divided by the principal minus the interest. Okay, so it's the 650 divided by the principal, 5,000, minus the interest. Okay, so it's equal to my interest divided by, I'm going to need parentheses, okay, the principal minus the interest, or 14.94. Okay, we knew it was going to be higher. Okay, if you're doing these, is it going to be a lot higher in a case like this? Discounted, if you're calculating what the actual rate is, the effective rate, it should be higher, generally speaking. Yeah. Okay, so assume that, but it's probably not going to be 4 times higher. If you get a number like that, you know that you're probably wrong, and you probably have to go back and take a look at it. Okay, then I did another one where it wasn't for the full 360 days, because I think that's like, I'm not sure if your guys is this for the full year or no. Okay, so I wanted to give a demonstration of that. I said, what if somebody borrows $5,000 and their interest is $200, but they only keep it for 180 days, right? So now I've got my interest, or 200, divided by 5,000 minus 200, so 200 divided by 4,800 times 360 divided by 180. Okay, and I can just put the whole thing into one formula here if I want. So my interest divided by, I'm going to need a parentheses, my principal, 500 minus my interest, and a parentheses, and times my 360. Oops, I don't have that down any place, so I'm just going to put a parentheses and type in 360 divided by my days outstanding, which is 180, parentheses. That should work. Okay. 8.33% is my effective rate on a discounted loan there. Okay, and they just gave me the interest, and that's the way they did on yours. They gave you the interest. You didn't have to actually calculate it like I did up here. Question 8. A couple ways to do it. I'm going to give extra credit for you if you do it one way. Okay, you've got 2 rates, right? And it just says add the amount, right? So if you got 11% is one rate, and you got 5,000. Remember how I calculated what your interest was up here? Okay, and on this one you got 9.5%, and you got 5,000. But this one's also going to add an extra 45. Okay, here's the extra credit I'll give. Okay, if you actually calculate the discount, okay, on this one your discounted amount that you want to calculate is just the $45. This is how they actually calculate fees that you pay, like on a mortgage loan, where you have to pay some non-refundable fees up front, and it's not the fees that go for appraisals and those types of things. It's usually discount rate, or discount points that they'll call it, Okay, and this is how they actually figure it. So you'd figure the $45 is your interest, $5,000 is your principal, and you'd get an effective rate, but then that would be added to the actual rate, is how you would calculate that. So I might give you a little extra credit if you want to mess with that. 18, now we're talking about effective rates on like installment loans, where you have more than one payment. And how do you figure that? So, you know, in the old days, probably before they had calculators and they had to, you know, handwrite everything, they probably did it like this. You'd borrow 10 grand, say, and your guys' question is for different amounts, 5,300 and 5,300 principal and 400 in interest. But they probably would, you know, you'd borrow 10,000 and they'd lend you 10,000 and they'd charge you $500 interest, say, for the year, and what was the effective rate on that? And so we can calculate that, and really pretty easily, because we got a formula. Effective rate's 2 times the annual number of payments times the interest, and divided by the total number of payments plus 1 times the principal. So I kind of here I just put in this is the top part of that formula, 2 times the annual, and this was for the second one. 2 times the annual number of payments times the interest divided by, and this is the bottom part, the total number of payments plus 1 times the principal. Okay, and you can sure put the whole formula in here. It's not too bad, really, or too difficult. So you can even make this chart a little bit bigger. You could, we'll leave it like this, I guess, and just walk through these. So, okay, so for the annual payment, let's do that. Okay, so I got 2 times the annual number of payments. If there's an annual payment, then it's just 2 times 1, which we know is 2, times the interest. So I got 600. Okay, so that's the top part of my equation. Bottom part of my equation is the total number of payments plus 1. So that on an annual payment, I've got parentheses equals 1 plus 1 times the principal, times my principal up here. And that gives me my answer. Okay. And I've moved it up here, and I've got the whole formula in and calculated it, and away we go, right? So let's do the second one I got on there. Let's do quarterly. So quarterly, we'll do this one here. So 2 times annual number of payments, that'd be 4 payments. So I can say this is equal to 2 times 4 times my interest. Okay. And this is the bottom part of the equation, so it's total number of payments 4, so I got to go, it's equal to 4 plus 1 parentheses times the principal. And let's see, that gives me my quarterly answer there. So yeah, it's pretty cool. You know, you could probably do it like this too. I got thinking about it just while I was doing that. So annual would be 1 payment, semi-annual would be 2 payments, quarterly would be 4 payments, and monthly would be 12 payments. Okay, and so you could simply say then that this is equal to, and you're going to need a lot of parentheses, but parentheses 2 times number of payments, okay, times the interest, and I'm going to put dollar signs on that and put parentheses, okay, and then divided by, I'm going to need parentheses, I think I'm going to need a couple, okay, the total number of payments, so it's this plus 1 parentheses times the principal, and again I'll hit my F4, makes that dollar signs, and there we go. Same answer. Doing it that way, I can do this. Hopefully none of these change. They didn't. So you could also do it that way and copy it down as long as you got all your dollar signs and everything in place. So there ends the lesson for today about interest rates. Okay, some fairly simple stuff. Shouldn't take you too long, I hope, especially as long as you follow along with what we provided there. So good luck on the assignment, and we will talk to you soon.